Today we are going to look at a topic called metabolism and glycolysis in particular. So, by the end of this video, I hope everybody will be able to define metabolism and give its types, define glycolysis, and describe and illustrate glycolysis pathway, and be able to calculate the amount of ATP which is produced in a single process of glycolysis, and state some importance of glycolysis. So let's begin by looking at the definition of metabolism. This is a process where living organisms acquire and utilize or make use of free energy which is available for various body functions. And we have two types of metabolism, namely anabolism and catabolism. So in anabolism, there is a synthesis of complex molecules from simpler molecules. For example, synthesis of glycogen from glucose. So you are starting with simpler molecules and you're ending up with complex molecules. For example, if you want to have a carbohydrate, you start with simpler molecules like glucose, so you end up with a bigger molecule. And for this process to happen, you need energy. So in anabolism, energy is utilized. And in catabolism, which is the breakdown of complex molecules to their constituents, you're starting with bigger molecule, and you're ending up with smaller molecules. For example, in food digestion, so energy is produced in this process. So this energy produced in catabolism, catabolic reaction can be used in an anabolic reaction. So now let's look at glycolysis. Glycolysis is a series of metabolic processes that metabolize glucose molecule into two pyruvate molecules, and this process occurs in the cytosol of the cell. So to degrade one molecule of glucose, you need 10 steps, which are characterized by an enzyme for each step, and you end up with two pyruvates. So you are starting with a 6 carbon molecule glucose, and ending up with 3 carbon atom molecule pyruvate. I'm sorry, that's molecule and atom. Yeah. So by the end of the crisis, you produce high energy molecules, which are ATP and NADH. So ATP just stands for adenosine triphosphate, and NADH is a reduced nicotinamide adenine dinucleotide. So let's now look into steps which are involved in glycolysis. So the first step or first reaction involves the phosphorylation of glucose. So you have your glucose molecule at the beginning, and you need ATP. ATP is utilized. So a phosphoryl group is taken from ATP and are being attached to carbon number 6 of glucose, as you can see on the figure. So this process is catalyzed by an enzyme called hexokinase, and glucose is turned to glucose 6-phosphate. 6 just indicate the position of phosphoryl group, which has been taken from ATP. So since you had ATP and one phosphoryl group has been taken from it, so you end up having ADP. Yeah. And in reaction 2 involves the isomerization of glucose 6-phosphate. So glucose 6-phosphate, which has been produced in the first step, is isomerized to its isomer called fructose 6-phosphate, and this process is catalyzed by an enzyme called phosphoglucose isomerase. So this process, as indicated with arrows, it's reversible. So you are isomerizing G6P. And this process is followed by the second phosphorylation of this molecule, not second but another phosphorylation process. So you are phosphorylating fructose 6-phosphate. Now since the ATP is providing a phosphoryl group, this phosphoryl group will be attached to carbon number 1 of the fructose 6-phosphate. Now you end up having fructose 1,6-bisphosphate. So this process is catalyzed by an enzyme called phosphofructokinase, and ATP is used, and you are ending up with another ADP molecule in this process, just like in the first process of glycolysis. The fourth reaction involves the cleavage of fructose 1,6-bisphosphate. So we are having a 6-carbon molecule or compound, which is split into 2 3-carbon compounds called glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. So this process is catalyzed by aldolase. So it's like you are splitting or breaking fructose 1,6-bisphosphate into these 2 trioses. So trioses just indicate that hydrocarbons having 3 carbons. So that's it for step number 4. In reaction 5, there is isomerization. So triose phosphate isomerase, which is an enzyme, characterizes the isomerization of dihydroxyacetone phosphate into glyceraldehyde 3-phosphate. So for glycolysis to proceed, you only need glyceraldehyde phosphate. So DHAP cannot proceed in glycolysis. So since these are isomers, you can isomerize DHAP to GAP. So you will end up with 2 GAP molecules, which will proceed in this process of glycolysis. Points to acquire before proceeding. We started with 1 glucose molecule, which is a 6-carbon molecule, and in reaction 5, 2 trioses are produced, and each GAP molecule, which is produced in step number 5, proceeds in a different path. So, and we have used 2 ATP so far. So let's now look at reactions, and the following reactions will produce energy, but not all of them. So we'll look into those reactions which are producing energy. So in step 6, or reaction number 6, which involves the oxidation of GAP or glyceraldehyde 3-phosphate to form 1,3-bisphosphoglycerate. So in this process, glyceraldehyde 3-phosphate dehydrogenase catalyzes the process. So NADH is produced. So NADH is a higher energy molecule. Now we can say from step 6 we started now producing energy. So NADH is produced by reducing NAD+. So we are ending up with 1,3-bisphosphoglycerate. So we started with GAP and NADH plus and PI, which is an inorganic phosphate. And in reaction number 7, we are now starting producing ATP. So don't be confused that this is a process where energy is starting being produced, but this is energy in particular, ATP. So first ATP synthesis, and since we produced 1,3-BPG, which is just a shortcut for 1,3-bisphosphoglycerate, it is dephosphorylated, or a phosphoryl group is removed from carbon number 1 and ATP is produced. So now we started with 1,3-BPG and a molecule of ATP. So ATP again and a phosphoryl group, so we have ATP at the end of the process and 3-phosphoglycerate. And in reaction number 8, there's a phosphoryl group of 3GP, which is transferred to a second carbon of 3GP, and I'm sorry, a phosphoryl group of 3GP is transferred to a second carbon, and you end up with a 2-phosphoglycerate. So the carbon in the phosphoryl group in position 3 is transferred to a position 2 of this molecule, and this process is characterized by phosphoglycerate mutase. So mutase just transfers the functional group from one carbon to another. So that's what happens in reaction number 8. Now in reaction number 9, there's a dehydration of 2-phosphoglycerate. So this process is catalyzed by enolase, and you end up with having phosphoenol pyruvate, so which is abbreviated PEP. It is called dehydration just because you are removing one OH group and hydrogen, so these molecules combine forming a water molecule. That's why it's like you are removing water from 2-phosphoglycerates and you're ending up with phosphoenol pyruvate. So it is called dehydration just because you are removing water. And the final step reaction in glycolysis involves the second ATP synthesis or production. So pyruvate kinase catalyzes the formation of pyruvate from phosphoenol pyruvate, and ATP is also produced in this process. So you are inputting ATP and inorganic phosphate, and you're ending up with a pyruvate and an ATP molecule. So remember, from step 5 we've started